Okay, 3-1. Now, it turns out that there are three combinations, three different cases to what a system is going to look like. All right? I want you to think about the graphical representation of a system. All right? Now, who cares about, the details? I just want to give you what those three cases are first. We're going to name them, get some characteristics of what they look like. The first one is that you have a line coming down like this, or in some direction, and you have a line coming down like this, in some direction. Okay? We're talking about the number of places that these graphs have in common. First of all, this right here, the point where they intersect, is called the solution point, or the solution. Your job for the next 3 weeks is to be able to find out where that solution is located. Alright? Would you agree that that solution right there is a point? Yeah? Would you agree that that solution right there is a coordinate or an ordered pair? Yeah. Right? So this solution point, I want you to find as x comma y. Example, 2 comma 5, 3 comma 2, negative 1 comma 0, and so on. Alright? Now, it turns out that in the first case, let's call this case number 1, there is one solution on case number 1. The reason that there's one solution is that the two lines are intersecting. Okay, here we have like characteristics of what this graph is. There's 4 for each one. 4 for each one. The third, okay, there's one solution because the lines are intersecting, and they're intersecting because, let's say this, different slopes. What do you know about two lines that have different slopes? Don't they have to intersect somewhere?
Yes.
Because I know two lines that have the same slope are going to be parallel to each other, and that'll come in the second case. And the fourth is, what is it called? Okay? This is going to be called consistent. It is a consistent system / independent. Now, I'm not super concerned about the consistent part. I just want you to know that it's independent. Each variable is independent of one another. The x and the y, it doesn't matter, right? This is my line, whatever the equation may be. We'll look at it in a second. This is my other line, whatever the equation may be. We'll look at it in a second. But this coordinate, x comma y, is independent of the other. Now, my next case, give me a line that looks something like this, and give me another line directly on top of it, which looks something like that. And I'm going to put a little note on here so we know. Same line. Do you think it's possible for me to give you two equations and those lines be the exact same thing?
Yeah. Yes.
Okay, well technically the equations would be the same, but could I do something to one of the equations to make it look different and have it actually still be the same line? Absolutely. Alright? And here's what we're going to say. Infinitely many solutions. How many different points touch both lines in case number 1? In case number 1, there's 1, right? It's that one right there. How many points touch both lines in case number 2? Infinitely many. This is case number 2. Alright? So instead of intersecting like in case number 1, these are going to be the same line. So instead of having different slopes like in case number 1, these, since they're the same line, are going to have the same slope. And these, this line, like in case number 1, what is it going to be called? It's going to be called consistent and dependent. Why is it dependent? I don't really care about the consistent. I care that you can tell me that it's dependent. Why is it dependent? It's the same line. It depends on the other line. Okay? One line depends on the other for them to be the same. That's why it's dependent. And how about case number 3? This is the most curious case. What I have are two lines that are not the same, that are exactly parallel. And by parallel, I mean never touch. Yet. And what I mean here is zero solutions. How many points touch both lines?
0.
None. Those lines will never touch. Did you hear that? These are going to be parallel lines. These lines are going to have the same slope because they're parallel. And what do you think this system is going to be called? If the first two are consistent, because there's a point, at least one point touching each one, here I have no points touching both lines.
Non-consistent.
Inconsistent, that's right. INCONSISTENT. 12 letters. Now, here's where the calculator is going to come in handy. Alright, so let's turn this baby on. I want to give you the step-by-step process in having the calculator do all the work for you. Alright, so what we're going to do is this. Use the table, okay, to solve.
Do we need to write that?
Yeah, yeah, use the table to solve.
I use your calculator today.
Where's yours? Use that one, it's fine. Now, here's what we're going to do. Now, the book does a little differently, but I want to use technology, okay, in order to solve the problem for us. What are these going to look like? All right? What does a line look like as an equation?
Y equals mx plus b.
Y equals mx plus b is probably the most common way to go about it, okay? So here's the example. Let's call this x1. I'm going to give you a line, and it is x plus y equals 3. And here's my other line, 2x plus y equals negative 6. Do you think these lines will intersect somewhere?
Yeah.
Why?
Different slopes.
Correct, Mr. Danko, you are right. If you were to think about this, like if I want to plug this in the calculator, which we're going to do in about a minute and a half, I got, what's the button called? Y equals, right? Let's get y equals on this. So subtract x. I'm going to graph this in the calculator. Y equals negative x plus 3. Hold on to that for just a second. Let's do the same thing to the other one. How do I get y by itself?
Add 2x.
Let's add 2x, Mr. Drinkwine. Add 2x, add 2x. Y equals 2x minus 6. Now, don't worry about the graph right now. It doesn't matter. What is the slope of the line? Right up here.
Negative 1.
Negative 1. What is the slope of the line down here?
2.
Since the slopes are different, they will intersect somewhere, right? Would you agree?
Yes.
They have to, because the slopes are different. So, what I'm going to do is I'm going to graph this in the calculator as y1. I'm going to graph this in the calculator as y2. I want you to do the same thing. Here we go. Hit y equals negative x. By the way, hit negative x, not minus x. Negative x and minus x are very, very different.
Positive 2.
Minus x plus 3, negative x plus 3, and the other line, put this under y2, 2x minus 6. Now, don't even hit graph, because I don't care about the graph. What do the directions say?
Use table.
Use the table. Now, do you see where it says second graph? What is that yellow word above the graph button?
Table.
Table. Hit second table, and the table comes up. Okay? So let me just copy a couple of these down and show you what it is that we're looking for. The table is going to be xy, but it's really going to be x, y1, and y2. Now, your job is to investigate. Move up and down the list and find out where the y1 and y2 values are the same. Now, I'm going to start with just a couple points. 0, 1, 2, and 3. And I did those ones on purpose so that I could include the solution. Okay? For the people watching on the videos at home. Okay? In your nice, cozy bed while we're in hard steel metal desks learning. You're in your nice, cozy bed learning from home. That's fun. It's called a flipped classroom. Alright, so what are the zero values? 3 and negative 6, 2 and negative 4, 1 and negative 2. And what do you notice at the 3 value? Aren't they the same?
Oh my god.
So where is my solution? 3, 0. That's the point on the graph where those two lines intersect. You want me to prove it? Watch this. Hit the graph key. Hit the graph key. Guess what?
Oh snap.
There's one line. There's the other line. Okay? Let me show this here. Where do they intersect?
What would happen to mine? It's a crap.
3, 0. That's amazing. Okay, do this. Hit zoom 6 for me. That'll put it back to standard graphing.
Okay.
Zoom is right top center. Did it work?
Yeah, it definitely works.
Good.
How is it just
Okay, man. Does that make sense? Does that make sense to you?
Oh, I think I was in
Now, the second type, and this is the longest of the 3 kinds that we're going to look at today. And here, this is the solution. This is all that I want. See that, what I just circled? That's all you need. You need the table and then the coordinate. Write it as a coordinate. From now until... No, like Thanksgiving. Okay, in all of chapter 3, you are looking for a point. Your job is a x, comma, y. Where do these lines intersect?
So the answer, we have to do that x, y1, y2.
Yeah. Just write down a couple values on the table and then tell where they match up.
Alright.
Solve by graphing. Okay, now, I'm going to give you some graph paper for the homework. And we're going to say, okay, I'm going to put these lines on a graph and see if I can continue on until they match up to be the same point. Alright, so let's start out with a simple one here. Y equals x plus 3 and y equals 6x minus 2. Okay? So the question is, what are we looking for? Are we looking for a point?
Yeah.
Let's put them on a graph and see if we can figure out where the point is. And it turns out that graphing is impractical. Okay? Graphing is not very, it's very accurate if your answers are whole numbers. But it's not very useful or practical or friendly or, wise. Top line. Line number 1. What's the B value? 3. Let's go up 1, 2, 3, put a point. Top line. Line number 1. What's the slope?
6.
Up 1 over 1.
Up 1 over 1, okay? And here's what I want you to do. Go up 1 over 1 a couple times. Like 3 times. Maybe in both directions. So you can go down 1 left. Down 1 left, okay? So it takes me here. Don't draw a line yet because I'm not worried about it. I just want to see if I can figure out where these two babies cross. Bottom line. What's my B value? Negative 2. So let's go down 2, put a point. Okay. What's my slope? 6 over 1. So let's go up 1, 2, 3, 4, 5, 6, and over 1. And guess what? It landed right on it. And that is what you want to happen every time. So now what I can do is just, draw my line up. I need a ruler, but it's better up here, okay? I can draw my line right here. Okay, and this is not quite good enough, but instead I need to tell where the intersection point's going to be. What's my solution? Is that over 1 up 4? How about 1 comma 4? That's what we're doing today. Okay?
I like this way.
Let's get started.
Let's increase the difficulty a little bit here, okay? Write this down. Y equals 1/2 x minus 4 and negative x plus 2y is equal to 6. Question. Is the top line graphable from how it is now?
Yes.
Yeah.
Good, let's circle it. We're done with that one. This one I got to get y by itself in order to graph it. Okay? Let's get y by itself by adding x to both sides. Write this down. Add x, add x. 2y equals x plus 6. Let's divide by 2 on both sides. Divide by 2, divide by 2. Y equals 1/2 x plus 3. So that one's graphable now. Okay? Let's just do this one really fast because you might be able to look ahead and see what's going on here. Why? He said that the lines are parallel. Why? Because the slope of this line is 1/2, the slope of this line is 1/2. So let's just do it real fast. My b value down 1, 2, 3, 4. My slope is 1/2. Let's go up 1 over 2. Okay, there's my line. Something like this. Okay, that took how long? 10 seconds? This one, the b value is 1, 2, 3. What's the slope? 1/2. Let's go up 1 over 2. Okay, there's my line. Guess what? No solution because these lines are never going to intersect. Is everyone okay with that?
No.
It's trippy.
Last one.
Okay.
Last one, and then we identify, and then we're done.
Okay.
Okay, coach.
Write this down.
Okay.
3x minus 2y equals negative 6. 3x plus 3y equals negative 6. Let's think about this for a second. Do these two lines have the same slope? Yes or no?
Yes.
Oh, you could say yes or no or I don't know.
You. Yeah.
Let me give you a hint. Let me give you a hint. The lines have the same slope if the A and the B are the same. Okay?
They are.
My A's are both 3, but my B's are different, right? Because that way when you take the X's over and divide by that number in front of Y, it's going to be the same. But in this case, it's not, is it? Oh, no, hold on. Here we go. Let's do, which one do you want to do first?
3x.
Well, they're both 3X, silly.
Well, the first one.
The first one, okay. Let's subtract 3X from both sides. Okay. Now, Sherman, I'm going to bring this down here because I don't have room. Okay.
Have fun.
All right. Okay. So let me write this right here. Negative 2y, right? Negative 2y equals negative 3x minus 6. Okay. Say it again. Okay, let's divide by negative 2. Myers, what's my final line going to be? Y equals what?
Oh, goodness.
Come on.
Negative 3x. No, 3x, right?
3 halves x, good.
Minus, no, 3.
Plus 3, thank you very much. So there's my line. We'll graph that in a second. Okay, Sherman, now we're going to do this one here.
Alright.
All right, so let's take the 3x over here. Okay. So 3y equals negative 3x minus 6. Okay, let's pause. Not pause the video, just like pause a second. Don't pause the video.
I wasn't gonna.
Good. Now let's divide by 3. Oops, I forgot to pause.
Oops.
Now, what's the line going to be here, Sherman? Negative 3 over 3.
Negative x.
Negative x, correct. Then what?
Then you divide by negative 3 to negative 6.
Yep, negative 6 divided by 3 is negative 2, isn't it?
No?
Is that right?
Wait, isn't it what?
Negative.
Just go for a negative 2.
Yep, we're good. Now, do we have y by itself on both?
Yeah,
Okay, let's graph them. Just continue your lines for a few dots in both directions and see if you can figure out where these things are going to meet up. Okay, that's what you're trying to do.
Don't kick the camera.
That's it.
Now, top line first. My b value is negative 2, go down 2, put a point. Okay? Top line, the slope is negative 1. Go down 1 over 1 and put a point. Down 1 over 1, put a point. Okay, and what I'm going to do, just to continue, I'm going to go up 1 and over 1, put a point. I'm going to go up 1 and over 1 and put a point like this. You don't have to connect them yet, just continue along. Bottom line. Okay, my b value is 1, 2, 3. Now watch this very closely. What's a slope? 3 halves, right? Look at my line's down here.
Let's go down.
If I go up 3, over 2, it takes me, I'm going away from it. So instead of going up 3 and to the right 2, let's go down 3 and to the left 2. And guess what? It took me right on top of that point, and that's exactly where I wanted to be.
Dang.
Believe it's not butter.
That's crazy.
Sherman, where's the solution?
What?
Where's the solution?
Right there.
What comma what?
Oh.
You can write in your homework, right there. Give me a point.
-2, 0.
-2, 0 is right. Okay. -2, 0. Okay. Now the last thing that we're going to do today has no graphing involved, but
Thank you.
what, I'm sorry?
Thank you.
Yeah, no problem. And this is identify. Okay, Danko, you're going to be good at this because it's talking about just looking at what the slopes are. What the slope is. Identify as, now there's 3 possibilities. Independent, misindependent, dependent, or
Inconsistent.
inconsistent is correct, Brooke. Inconsistent. Okay? Now, you don't have to graph these. Don't graph them. What do you want to look at?
Slope.
You want to examine the slopes. And if you examine the slopes, all right, it'll tell you exactly what it is that you need to find. We'll do 2 of these. Number 1. 1/2 x plus y equals 5. Leave a gap. Leave some space. 2y equals negative x minus 3. Okay. Okay, top line. What's the slope of it? Come over here so I can see. Okay, this line right here. What's the slope of that line? Close. Close.
Oh, yeah.
Negative 1/2. Why?
Why?
Hey, get y by itself, take this over here, right? So my m value is negative 1/2. That's what I'm looking for in this. In the identify, just worry about the slopes, because the slopes will tell you everything you need to know. Drink wine, what's the slope of the bottom line?
Yeah, maybe 1/2.
Why?
Divide by 2.
Yeah, it's times 2, right? So if you divide by 2, technically if you divide by 2 here, this is negative 1 over 2. So the slope of this is negative 1/2. The slopes are the same, but are they the same line or are they parallel lines? That's what I need to know. Now, the slopes are the same, right? So you know it's not independent. Okay? Are these the same line or are they parallel lines?
Parallel.
Why are they parallel? Why?
Because the b is not the same.
That's correct. Look, my b value here is 5. My b value here is definitely not 5. So these lines are going to be parallel. So these are parallel lines. Okay? So which one of those do I have for it to be parallel lines?
Inconsistent.
It's going to be inconsistent. So that's the type that we're going to have here.
Sweet.
Okay? Let's just do that one more time, and then we're going to wrap this up.
Go see.
I don't like this.
Last problemo.
Rabla.
Write this down. Sherman, how's our time doing? What's the time?
23 minutes.
Whoa! Y equals 3x plus 2.
Same line.
And negative 6x plus 2y is equal to 4. Okay. Top line, what's the slope? 3.
1/2 greater than.
No, that's just a
That's the same line.
equal sign
Oh, I
thing.
was about to say.
This one's dependent.
Oh.
Yeah. Bottom one's 3,
Oh.
2.
Say it again.
Bottom one's 3, 2.
How do you know that?
You add 6, and you got divide by 2.
If you bring this over here, you divide by the 2, which we might need to do real quick to see something. So 2y equals 6x plus 4.
Inconsistent.
Look at this.
Same thing.
What happens?
Identical.
Correct.
So it's dependent.
Okay? These are going to be the exact same line. Because it's y equals 3x plus 2, y equals 3x plus 2. Which one of these is it?
Dependent.
That's dependent.
It's dependent.
I like these 3 easy.
I got them
Okay.
mixed up.
Any questions? Good. Thanks for watching.